Hi, this tutorial covers theoretical probability, also known as the a priori method of calculating probability. So, there are three ways to make a probability statement or to calculate probability. The first way is theoretical probability, also known as the a priori method. The second way is what's called experimental probability or relative frequency probability. And the third one is called subjective probability. So this tutorial is going to concentrate on theoretical probability. So let's take a look at a definition of what theoretical probability is first, and then we'll take a look at the formula also. So theoretical probability is a method of calculating probability where the probability is the ratio of the number of equally likely ways an event can occur to the number of possible outcomes. So remember, ratio means division. So you're going to take the number of equally likely ways an event can occur, and you're going to divide that by the number of possible outcomes. So this is also known as the a priori method or the classical approach to probability. All right, so if we take a look now at the formula, so kind of putting that definition into more of a formula, it says if all the outcomes of an experiment are equally likely, okay, that's pretty important. All of those outcomes do need to be equally likely. The probability of event E, denoted as P of E, so this is what's called probability notation. And with probability notation, the capital P stands for probability. Then what's in the parentheses is what the event you're trying to take the probability of. So this is always read a P of E. So probability of event E. Okay, and P of E then is to calculate the probability of event E. If we're dealing with theoretical probability, it's the number of outcomes favorable to E divided by the number of outcomes in the sample space. So all of the possible outcomes there. Okay, so let's take a look at an example here. So let's first of all look at what our chance experiment is. So the chance experiment is to draw a card from a standard deck and note the card's suit and value. Okay, so we're going to let event A be the event of drawing a queen, event B the event of drawing a red card. Okay, so if we just think about our standard deck of cards here, just shuffle them up. I'll simulate the chance experiment, so give it a few shuffles. And then all I'm going to do now is take one card and draw it off the top. Okay, so that would be the ace of hearts. Okay, so we're going to let event A be the event to draw a queen, B the event drawing a red card.
Okay, notice event A was not met, event B was met.
Okay, so that would be one trial of my chance experiment. If I wanted to do a second trial, okay, again, I'd shuffle them up. And then I would need to draw a new card. Okay. All right, so if we now want to calculate the theoretical probability of each of the two events, if we're looking at the probability of A, the probability of drawing a queen, okay, so we need to calculate a ratio. So it's the ratio of the number of outcomes favorable to E divided by the number of outcomes in the sample space. Okay, so since the likelihood of all of the cards, drawing all of the cards, or each and every card, is the same, and there are 52 cards, we're going to put 52 on the bottom of that fraction because that's all of the cards in the sample space. Now the event of drawing a queen, okay, so there are 4 queens in every deck, one for each suit. So this ends up being 4 out of 52. Okay, so probability. So one way to notate probability as a fraction like this. Generally, you don't want to reduce a probability fraction. It's more meaningful to leave it this way. But what you can do is you can change that into a decimal. Okay, so let's go ahead and do that. So we'll do 4 divided by 52, and as a decimal, that's about 0.077. Okay, so this is approximately equal to 0.077. So a little less than an 8% chance of drawing a queen on one draw. Okay, now let's do event B also. So the event of drawing a red card. Okay, so we want to do the same thing. We want to do the ratio of outcomes favorable to event B divided by the number of outcomes in the sample space. So this isn't going to change. This is still going to be 52. Okay, now if I want to figure out then how many outcomes are favorable to event B, so how many cards basically in the deck are red. Okay, so the red cards are the hearts and the diamonds. Okay, there are 13 cards per suit, so that would mean there's 13 hearts and 13 diamonds in each deck. So that's a total of 26 out of the 52. Okay, which of course is half of the deck. And if we divide that, we do get 0.5. So we have a 50% chance of drawing a red card. Okay, so what I just did was calculated both of these two events using theoretical probability. In theory, 50% of the time I should get a red card. In theory, about 8% of the time I should get a queen. So that has been the tutorial on theoretical probability. Thanks for watching.